basics as well, do like a Bitcoin 101 introduction. Rodney's going to lead us through that in just a minute. But before we get started on the presentation, actually, Joseph, you want to come up and make your announcement as well? You can go ahead.
Why don't I do it at the end?
Never mind, he's going to do it at the end. So we're going to start with Rodney then from Outlier, and he's going to walk us through Bitcoin 101.
Thanks, man. Hi everyone, my name is Rodney McKenna. I am the AML Compliance Ninja and Chief Operating Officer at Outlier Solutions. We are an AML consulting company that kind of fell down the Bitcoin rabbit hole a few years ago. I love to talk about this stuff, and this is probably the most relevant time that I've ever worn a Bitcoin shirt that wasn't just because it was like a Wednesday or a Tuesday. That said, my presentation, what I've done is I've kind of loosely based it off of Andreas Antonopoulos' book, Mastering Bitcoin. Anybody wants to know Mastering Bitcoin, Mastering Bitcoin is a great place to start. However, it can get a little technical, so there are other places that you can kind of start and dip your toes in. But the great part about this book is you could read it and get just as much. Like, I don't code. I'm not a super technical guy, and I've read this enough now that I can get 10% of the technical part of it. So no matter what your skill level is as far as computers, engineering, whatever, coding, programming, stuff like that, you'll get something out of this book. It's a fantastic resource. About the presentation, I'm trying to cram that book into this much time. So I'm going to go relatively quickly. I'm going to skip over a couple really technical areas. If there's something that I talk about that doesn't make any sense, throw your hand up and stop me. If there's something that you want me to elaborate on more, put your hand up and stop me. If you have any questions, whatever it is, stop me before we move on, and I will try to answer it. If not, maybe someone else in the crowd would be able to crowdsource an answer for that, but we'll see. So without any further ado, these are the bullet points that come from Andreas's book. If you look through Mastering Bitcoin, those are most of the chapters in the core of the book. However, each one of these has somewhere between 10 to 20 sub-bullet points or subsections that can not be covered tonight because there's just not enough time or anything like that. So a quick intro to Bitcoin. This started, before we go into that. Bitcoin. If anybody's not familiar, there are only ever going to be 21 million Bitcoin. We will not really speak to a lot of that tonight. It's more on the technology. What we're going to talk about tonight is what makes Bitcoin Bitcoin. The 21 million applies more on the economic side as far as a fixed set of tokens, a fixed amount. And I won't get into that, but each Bitcoin is broken down into 100 million Satoshis. And one of my favorite quotes that I heard when Safin was in town is that there's nothing that is more certainty in life than a Bitcoin transaction with 6 confirmations. If that doesn't make any sense to you, hopefully it will by the end of tonight. So around a little over 10 years ago, Bitcoin, the website, bitcoin.org, was first registered. The white paper was released. That's coming up on its 10-year anniversary in a little over a month. The first block, which is referred to as the Genesis block, was mined in January. Shortly after that, Satoshi and Hal Finney conducted the first Bitcoin transaction. And if you want my opinion on that, come get me afterwards. And then in October of 2009, the first actual exchange rate of Bitcoin was published. And as you can see, that was $1 equaled 1,300 Bitcoin. And that's when you see all the sensationalist newspapers. If you would have invested in Bitcoin in 2009, you'd be a gazillionaire now. Which at that point, nobody invested in Bitcoin. People saw the technology, believed in it, and wanted to live. So what is Bitcoin? It is a peer-to-peer decentralized network, which is the protocol. So that's the base layer of Bitcoin. The blockchain, which is kind of the background and the under the hood piece, is just a public ledger. That's all it is. It's a full list of every Bitcoin that's ever been mined, created, transacted, transferred. So every Bitcoin that I've ever sent to somebody, I could go and find and see where they sent it. I couldn't see who they sent it to, but I could follow that Bitcoin as far as it wanted to go. So if anybody's heard that Bitcoin is anonymous, that's inaccurate. But Bitcoin is pseudonymous. So if you can tie a wallet to a person, then you're able to figure out where that Bitcoin is traveling. So now that exchanges are requiring identification, it's really opened up who's sending what, where, and how much. It's good and bad depending on who you are on that conversation. The consensus rules we will get into at the very end. They're a really complicated way of saying that roughly at this point, I think it's 10,000 computers around the world run a full copy of the Bitcoin blockchain, and they all agree that that's the current and accurate version of that blockchain. And then proof of work. So proof of work is kind of how the mining is completed. It is, in short, a really, 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 really complicated math problem. Again, we will cover that more later. So as I said, Bitcoin is not anonymous, it's pseudonymous. Another point, sorry, before I go too far. This presentation will be posted on the Meetup group, so anybody that wants it will be able to download it and go through it. So there's 60 slides or something like that. I'm only going to try and get through about 40. And then there's a few more afterwards that just have general information that you can kind of go through at your leisure. So what I was saying before with Safe's comment about 6 confirmations, once the blockchain is moved that far down, so there's been 6 blocks mined from your transaction, the amount of computing power it would require to reverse that transaction is almost non-existent at this point. We were talking about quantum computers before. It's possible, but it's still verging on not possible, because in the last 6 months, I did this presentation, there's something similar to it last year in September, and I had all of the numbers from last year in September for how much hashing power there was, how many transactions there were, what the price was, everything like that. And as I was going through it, there's I think it's 100 million times more computing power going into the blockchain than there was last year. Like it's crazy. It's getting into words that I've never heard of, like an exahash and a pentahash, and really, really complicated things. Basically, because of all that computing power, that means that it can't be misappropriated, it can't be changed, it can't be altered, it can't be spoofed, it can't be double spent, which double spent is, I think, covered. I'll cover double spending. So this is a question I get a lot, which is kind of funny, of who owns Bitcoin? If somebody has a problem, who do they speak to? And there's no CEO of Bitcoin. There's no, I lost my Bitcoin, who can I call? There's no person like that. So nobody owns Bitcoin. But at the same time, everybody owns Bitcoin individually. So each of us who are a part of the network technically own some Bitcoin. So individually we're a part, collectively we are the network. You'll notice as I'm going through the presentation that Bitcoin goes both uppercase and lowercase b. That's not a typo, that's deliberate. Bitcoin, uppercase B, is Bitcoin generally as everything. Bitcoin, the protocol, the payment network, the ecosystem. So I just learned about Bitcoin and I think it's game-changing technology, capital B. Lowercase b is strictly the currency. So example would be, I just sent Bitcoin to Alice. Sorry, Joseph, you had a question?
Sorry, I'm not, just for the noobs, I guess, when you're talking about 6 confirmations in mining, what do you mean?
So 6 blocks have been mined on top of the one that your original. So we'll cover how transactions work in a bit.
I just wanted to make sure you were,
Yeah,
I was
I'll come
thinking
back.
as a newbie, I didn't know what that meant.
Yeah, so once transactions, in order to be confirmed, must be entered in a block when someone mines a new block in Bitcoin. And once 6 more blocks have been mined on top of it, in order to reverse all of that work that had been done, it would basically take more computing power than exists at this point. So this is the fun one that I did last year that has all of the numbers. And the really interesting part that I found were the numbers were very similar. So about this time last year, the price of Bitcoin was going to the moon, as everyone likes to say. It was going crazy. And this was just at the very beginning. So going through these numbers, the current market cap of Bitcoin at this time was $72 billion. It is now 110. Mainly a lot of that is because the amount of coins that have been mined over the course of a year. The number of blocks has increased fairly steadily. It's still at 12.5 Bitcoin per new block that is mined. This is what I was saying about the hashing power, which is the computing power that goes into the network. So there's roughly 43 million exahashes, where last year that was only 7 million terahashes. And an exahash to a terahash is 6 zeros. So they're really, really, really large numbers, as you will see in a second. This was really interesting too, because the volume of transactions, this number here, was only off by about 2,000. So it would last year was 205,000 roughly. This year it's 203,000. So the number of transactions occurring on the Bitcoin network were very, very similar. What was different was the volume, or the value being. So now there's a bunch of small transactions that are going through. Where last summer there were a lot of transactions, but they were big numbers. I don't know how that correlates to the price or anything, because I have no idea. But I thought that was really interesting when I was going through the presentation. So how Bitcoin works. I'll try and explain this generally, but it's hard to do. So double spending. So this was a big game changer, because Bitcoin is not the first digital currency. There's been numerous before, and a lot of those are referenced in the white paper. And what Bitcoin really did is, with the blockchain, it was able to solve the double spend issue. So if you think about something digital versus something physical, if I hand you a $20 bill out of my wallet, I can't take that same $20 bill and turn around and give it to you, because it's going to have the same serial number. Like, you probably could in theory, but actually you couldn't if you took both of those to the bank at the same time. If you think about that from a digital perspective of, let's say, an MP3, so the Napster days, if you young folk back there may not know what Napster is, one person would post an MP3, and everybody would copy that MP3. It wasn't that everybody had their own copy of the MP3, it was one that just went out to everybody. If you do that with money, then it's useless. Transactions, inputs, and outputs. This really comes down to, does Bob have the Bitcoin to send to Alice, and does he control the Bitcoin being sent? So when a transaction occurs, that's all that is happening. Is there's a little line of code that says, this is the transaction that wants to happen, and another little line of code that says, that can happen because Bob owns those Bitcoin and is in control of that wallet. Again, we'll cover that a little more detail in a bit. So Bitcoin's stability is based on distributed consensus. Distributed computing has been around since like the 70s or something like that. It's not something that's new. What's the big game changer in this is being able to relay information quickly, and a really, really odd term called Byzantine fault tolerance, which is basically that it doesn't have to be in 100% agreement all the time. It can be in 51 and 49%. That would err on more problematic than not problematic, but it doesn't always have to agree. we'll cover that more when we get into some of the blockchain specific stuff. When I did this, there was 9,898 full nodes operating at this time. A full node contains the entire copy of the blockchain all the way back to the Genesis block. So that node knows where every Bitcoin has ever gone, ever, and keeps a record of it. That said, there are numerous other types of nodes, lightweights, SPV. We'll get into that as well. And again, the big part of that is the ability to have agreement without 100% consensus. In a few slides, we'll talk about forks, which I'm sure if anybody's been following Bitcoin for the last year is probably 90% of what you've heard about is the fork between Bitcoin and Bitcoin Cash. I'm not going to talk about that tonight. So the blockchain, again, just a mechanism for distributed consensus. If you think about it from a simplified term, I don't like calling it a database, it is more of a ledger. So you have a shared ledger that everyone in this room has, and every 10 minutes, we've got to update it together. And we got to update it again 10 minutes later, and again 10 minutes later. And we've all got to agree that the current version is the correct version. So if Joseph decides that he's going to change his 10 to a 100, when we go to update it the next time, we're all going to notice to be like, why is Joseph's different? Well, 90% of us will be in consensus and we'll know that Joseph's a bad actor, and we'll throw his chunk out, and then move on to the next 10 minutes. And 10 minutes later, he'll be back to 10 where he was originally. There's no single location. So a lot of what happens when you get hacking and like mainly that type of thing, take the Equifax hack. That was a single server housed in a basement somewhere where all the data was just sitting there and there was no real copy of it. So you get into a single point of failure, which is a big power behind Bitcoin, is there's no single point of failure, there's no single point of control. It's distributed across, basically across the board. Nodes, keys, and addresses. This is very bland and simple. So as I was saying, a full node has the entire history of Bitcoin. Keys. So asymmetric cryptography produces key pairs which are required to facilitate a transaction. Asymmetric cryptography is one key creates the other key. So your private key, which is the thing that basically rules your Bitcoin, creates a public key, and it only goes in that direction. You can't take the public key and figure out what the private key is. It's impossible. And addresses are just a string of digits. So it's a hash of your private key that spits out a bunch of numbers and letters. They'll never use a 0, a capital O, or a capital I to avoid confusion. Wallets. So these are different types of wallets. A lot of them are very similar, they're just on different devices. So your desktop wallet is a program that you've downloaded and you saved as your desktop as My Bitcoin Wallet. Don't do that. Call it something else, call it something random. Hide it in a junk folder, whatever you gotta do. Mobile wallets, so you can download a wallet to your phone that you carry with me. I have on my phone 4 mobile wallets, just to try them out. Web wallet. So a web wallet is probably the most dangerous because you're now storing your Bitcoin on someone else's website that you don't know anything about that is online all the time. Hardware wallet. This is what is referred to as a cold wallet. It is not attached to the internet. So this is like a Trezor is a great example, probably one of the more popular, or a Ledger. And it's basically a tiny little USB key. Most of them have some sort of screen on them. You go into the website, you plug your USB wallet into your computer, you enter your little secret code and everything, and then it allows you access. But you can't access the website, your Bitcoin, whatever that is, without that key. Arguably, the best, safest place to store your Bitcoin is a paper wallet, if it's done properly. So paper wallet obviously can't touch the internet because it's paper. you run into the degrading factor. So if you have a paper wallet, which we've had the fun of trying to rescue a RoboCoin paper wallet that was spit out on receipt paper, thrown in an envelope and just stashed somewhere, and then realized about last year, when the price started going nuts, that maybe we should check and see if we can find that Bitcoin. And then multi-sig. So multi-sig is exactly how it sounds. It's a signature, it's a wallet that, say, me, Karen, and Joseph all have access to, and in order to move anything within that wallet, 2 of the 3 of us have to agree on it. So simply, a wallet is where your Bitcoin is managed. From your user interface perspective, that's what you're going to see. You're going to think that your Bitcoin's sitting in your wallet, which is not true. It's actually an interface created to manage your keys. So your keys control your Bitcoin, and your wallet holds your keys. Your Bitcoin technically never leaves the blockchain. An SPV is a simple payment verification node. I will cover those later, but that's basically any wallet is an SPV node. It only holds block header information, so it has the blockchain in it. It's only got 1,000 bytes or something of each block. HD wallets, which that's the crazy computer term for them. And basically what it's saying is your private key is derived from, typically nowadays, 12 random words, sometimes 24 depending on what you're using. Those 24 will create your private key or master key, and then from there you can create public keys, and then from there you can create additional keys. You can, within most new wallets, you can do all this without knowing what you're doing. So it'll say address 1, and then you can do address 2, and then you can do address 3, and then within there you can do sub-address. So if you're, say, using Bitcoin for business, it's a really handy way to keep track of who's paying you what and where it's coming from and stuff like that. So the 12 seed words were referred to as mnemonic. Nobody calls them that anymore. They are typically 12 letters or 12 words. Don't quote me on this. The last time I was talking to someone about this, apparently you only need the first 3 letters of each word. But if you buy Trezor, Ledger, whatever hardware wallet, which is my suggestion that you're using, they come with a recovery seed piece of paper. And the first thing you have to do is write down your recovery seeds. What that does is that allows you to, say you lose your Trezor, and now you can't log into the website that has your Bitcoin. Well, you buy new Trezor. Then when you plug it in for the first time, you enter those same 12 words that your last Trezor gave you. That recreates your wallet, because those 12 words, using asymmetric cryptography, will create the same public key hash as the previous time. If you change one letter, the output will be different. Alex?
Yeah, I think it's important to mention that those seeds, they're not, you don't have to buy Trezor again. It follows a standard called BIP39, so if you have your seed, you could actually use it with any wallet that supports it. So some people think that you buy Trezor, you always have to use a Trezor. It's not really